day to everyone. For today's video, I'm going to discuss to you the topic in Calculus 2, and this topic entitled the areas between curves. So now, have you familiar what is areas between curves? So, in Introduction to Integration, we developed the concept of the definite integral to calculate the area below a curve on a given interval. So in this section, we expanded the idea to calculate the area of the more complex regions. So we start by finding the area between two curves that are function of x, beginning with a simple case in which one function value is always greater than other. So we then look at cases when the graph of the function cross. So lastly, we consider how to calculate the area between two curves that are functions of y. So always remember, just as definite integrals can be used to find the area under a curve, they can also be used to find the area between two curves. To find the area between two curves defined by function. So integrate the difference of the functions. Sometimes it can be easier to integrate with respect to y to find the area. So now, finding the area between two curves. Let f of x and g of x be continuous functions such that f of x greater than or equal to g of x over an interval a and b. So let R denote the region bounded above by the graph of f of x. So below by the graph of g of x, and on the left and right by the lines x is equal to a and x is equal to b. So respectively, then the area of R is given by a is equal to the integral from a to b of f of x minus g of x dx. So now, we have here some examples. So for the example, finding the area of the region between two curves 1. So if R is the region bounded above by the graph of the function f of x is equal to x plus 4 and below by the graph of the function g of x is equal to 3 minus x over 2. So correction, it is x over 2 over the interval 1 and 4. Find the area of the region R. So have you seen the graph here? So this will be the example graph represent. In the graph shows the region between two curves is shown where one curve is always greater than others. So the region is depicted in the following figure. So we have a is equal to the integral from a to b of f of x minus g of x dx is equal to the a here is 1 and the b is 4. So have you seen this? Then x plus 4, which is the f of x, minus the g of x, which is 3 minus x over 2 dx. Then the integral of our from 1 to 4 of g of x over 2 plus 1 dx. Then it come up with 3 squared over 4 plus x evaluated from 1 to 4 is equal to 16 minus 7 over 4 equals 57 over 4. So the area of the region is 57 over 4 units squared. I have here other example. Finding the area of the region between two curves 2. So if R is the region bounded above by the graph of the function f of x is equal to 9 minus x over 2 squared, and below by the graph of the function g of x is equal to 6 minus x, find the area of the region R. So the region is depicted in the following figure. So have you seen the graph here? This graph shown the region below the graph of f of x and above the graph of g of x. So we first need to compute where the graphs of the functions intersect. The graphs of the function intersect when x is equal to 6 or x is equal to negative 2. So we want to integrate from negative 2 to 6 since f of x is greater than or equal to g of x for negative less than or equal to times less than or equal to 6. So we obtain or come up or we can get the f of x is equal to g of x, which is the f of x is 9 minus x over 2 squared equals the g of x, which is the 6 minus x. So 9 minus x squared over 4 is equal to 6 minus x. So then it come up with 36 minus x squared is equal to 24. So 24 minus 4x. Then x squared minus 4x, which is 4, we can get the negative 4x here. Then minus 12, which is 36 minus 24. Then it come up with negative 12. So equals to 0. Then it come up with the result x minus 6 times x plus 2 is equal to 0. This will be the solution. So a is equal to the integral from a to b f of x minus g of x dx. So this will be the formula that will be used with this kind of example. So the integral which is came from a, which is negative 2, and b is 6. Then the f of x, which is the 9 minus x over 2 squared minus the g of x, which is the 6 minus x dx. Then now the integral of or from the negative 2 to 6 of 3 minus x squared minus 4 plus x dx is equal to, it comes up with 3x minus x cubed over 12 plus x squared over 2 evaluated from negative 2 to 6 equals 64 over 3. So the area of the region is 64 over 3 units squared. So this will be the topic in areas between curves. If you are new to my channel, don't forget to like, share, and subscribe. And don't forget to hit the notification bell below for you to watch my next upcoming video. Thank you and God bless everyone.